G'day and welcome to Cartographer. Earlier this week there was a really cool announcement that I've been excited to take a look at, and that was by the wonderful team over at CoreOS introducing operators. And what are operators, you may ask? So operators are application-specific controllers that extend the Kubernetes APIs. So sometimes you have complex stateful applications that need a little bit more application awareness than the Kubernetes APIs provide. And you may look to something like an operator to solve the care and feeding of those kind of applications. So with this announcement, there were two operators that were dropped. There was an etcd operator and a Prometheus operator. So I've been dying to get my hands on it tonight. I've taken a look at the etcd operator, and I want to give you some insight to how that works to help you understand how you might want to use it and how it can help you operationally manage etcd. So there's some great README. The blogs are great. I'll link them all in the description. So when we think about operational tasks when it comes to etcd clusters, here's the ones that are currently supported. I think it's a great list, and let's just get into it and see how it all works. So first thing I'm going to do here is lay down the deployment for the operator, the etcd operator, and that's the controller that's going to take care of stamping out and feeding and taking care of etcd clusters. So let's go ahead and get that out there. Get. I wrote get because that's what I was thinking. Okay. Okay, so I've laid down an operator. So what we should see here is an operator's been laid down. It's running. We'll just quickly pop over here and take a look at what the operator deployment looks like. Fairly standard, straightforward here. The only thing that I've added is the PV provisioner to be the AWS EBS, and that'll come into play a little bit later. So assuming that we're up and running, we'll take a look at the logs to confirm. Okay, so we should be up and running. There's a few other resources that the actual operator creates on the Kubernetes API. So let's take a look at them. Get third-party resources. So we have this third-party resource, which is a new resource that the controller has created, and that allows us to define etcd clusters declaratively in a Kubernetes native fashion. The other thing that we'll take a look at, and it's got to do with storage, get storage class. We should have, okay, so we've created this operator backup storage class that we'll reference later, and it's using the AWS EBS provisioner. So we should be ready right now to go ahead and provision, create. Let's create a 3.1 etcd cluster, and that's all there is to it. So what I've done there is submitted a request to create an etcd cluster. What that request actually looks like, let's go take a look. So this is what I've submitted. So again, it's this new kind. The operator controller is looking for that new resources created of that kind, and it'll go and stomp them out. So I have a few things, knobs that I can twist here. I can lay down versions, backups, and size. And this is just a fairly straightforward. My cluster should almost be there, so you can see that I have 3 nodes, and it's also stomped out a backup tool. So let's go and confirm that these are actually up and running. kubectl logs, and actually I'll pipe to correct version. I'll just prove that we're on 3.1, so we're on 3.1 there. Now what I will do is connect to that cluster. So let me just get a port forward going, and we'll port forward over to 0, node 0, and etcdctl put foo and bar, good old foo bar. Okay, that's great. etcdctl member list. So we have a 3-node cluster up and running, and it only took me 2 commands. It's never been simpler. Fantastic result. Let's take a look at what else we can do. So we created a cluster. Let's do resize, for example. So let's resize. So what I'm going to do to resize is actually just update that request. So I asked for 3. I now want 5. Now the only caveat to this right now is there is a bug in the ability to do a kubectl apply on a third-party resource. So I'm going to have to submit this as JSON up to curl it up to the URL. So I've just written a little script, but this is the same manifest in JSON, and I've just upped the size to 5. So let me just submit that as a scale cluster command. So it's responded with, I now ask for 5. So what should happen is the controller should pick that up and make sure that I have 5. So we've added 3 there, and we should see 4 there once it's up and running. So again, fairly easy to make a change, very declarative. I had 3, I asked for 5. It's going to handle how that gets delivered. So right now I have 5 nodes. Let's just confirm. Fantastic. So I've got a member list here, we've got 5 nodes up and running. And the inverse is going to work as well. So we have 5 and now we want 3. Let's go ahead and just show you that. Okay, so I've submitted that, so now it's just going to take care of getting back down to the desired state, which is 3. Fantastic. So that's going ahead and happening right now. What are some other things we might want to do? So we've done a resize, delete, member recovery. Okay, so let's go ahead and look at deleting a pod fairly forcibly here. So we have cluster member 0002. Let's go ahead and do that. Okay, so 0002 has now been deleted. The cluster should say, well, I've got 2 and I need 3. It's going to go and resolve that. And what we should see here is, let me just fix my port forward. I will push it through to, I think I had 3 there. It's been a little destructive here. Member list. Yep, so we're in a good state. So as you can see, the controller is taking good care of me here. I'm in good hands with that operator. Okay, so we're up and running. Now this is an interesting use case, and it's great that they've covered this. What happens if the actual operator dies? So let's go ahead and see what that looks like. kubectl delete. So I've actually deleted the operator. That's terminating right now. Now the idea is here that this should be freestanding. Obviously if there's any adds, moves or changes to the etcd cluster, they won't be fulfilled until there's another controller. But the controller can come back up and read the state of what it's supposed to be and pick up where it left off, which is fantastic. So we'll wait for this controller to die. I think in the demo it actually says go ahead and just kill a pod, so we'll kill a pod 2. Okay, so no longer running, and we have 3. Okay, so we've just terminated 3. Now what you would expect here is, because the controller isn't running, it can't reconcile this this change in state. So until we bring up a new controller, we can't have we're not going to have our 3-node cluster. So that's terminating. What I'll do is then spin up, and we'll see the cluster reconcile and come back to the desired state. Great thinking there. I think that's fantastic. So disaster recovery we can take a look at as well. So we can write some data in here, and then we can just kill 2 pods and make sure we've got lost quorum, and then we can actually just recover from backup. So we can go through that. Actually, I may not go through that one just in the interest of time, but you could do that on your own. Let's do a cluster upgrade, which I think is fairly interesting as well. Okay, so let's create. So we're going to recreate the operator here. etcd. Okay, so that's recreated. Now what this should do is come up, see that there's we've already asked for a cluster, and it should reconcile that cluster, and we'll confirm that that actually looks okay before we move on. And let me just get my port forward set back up here. I'll push it through to 4, which I think I still have. Okay, so you can see that it's actually reconciled, and we should be able to do a member, and yay, we're back at 3. So that's that whole use case. Operator dies, then we lose 1 cluster member, but we still have quorum, so we're okay. So what I would like to do for the last of the demos, and just in the interest of time here, let's see if we can actually do an upgrade. So the way I'm going to do this is, let's go ahead and delete what we have, and that is done by deleting the request for an etcd cluster. Delete -f, and we ask for a 3.1, so we'll yank that. So we should see that cluster disappear. Fantastic, that is now gone. And let's go ahead and create a 3.0 cluster. Let's prove that we get a 3.0 cluster here. kubectl logs version. Okay, so we're on 3.0 now. So I wanted to illustrate going from 3.0 to 3.1 using this operator. So we have a 3-node cluster right now. Let's just get our port forward set back up, and sorry that this is it's just one such connectivity option that I have. Okay, so we have a 3-node cluster up and running. Fantastic. Let's go ahead and ask it to upgrade. Now the upgrade's exactly the same. I will show you what I'm going to do here. So I have a JSON file here, and all I'm doing is actually switching the version number here, and the operator will take care of pushing that out. So I've just written a script here. I've asked it to upgrade. Okay, and let's take a look at the logs here. So as this rolls out, we should see everything get updated. It's going to take a few moments while it does that carefully. So the documentation's all here. It took me probably only 5 to 10 minutes to get up and running, and only 15 minutes to walk through the demo. So that's what you can achieve. Let me see where we're at here. Okay, so you can see that it's actually restarted. There we go. So 0.0.0.0 is at 3.1 now. Okay, so you see the actual restarts here. Let's kick them all over. Okay. And I mistyped there. My apologies. We're at 3.1 everywhere. So that's an upgrade complete. And let's just prove that we actually have a valid cluster. So fantastic. I mean, I can't say how wonderful this is. It looks really so simple, but I know there is a lot of great work that's gone into this. So congratulations, CoreOS team. I think this is a great step forward for operators running applications of this nature, and I think it lays down a really compelling pattern. So thanks for joining. Happy to take feedback. Cheers.